Why do I prefer Clojure to Haskell? So this is going to be a very personal, very anecdotal, maybe even a little out of date discussion of my preference. I was asked, I'm going to give it. All right, my name is Eric Normand, and I help people thrive with functional programming. So it's a little late on a Sunday night. Had a long weekend and a long week, and I just want to get this out. I should be asleep, but I want to finish this up. So I have to tread very carefully here because I am comparing two languages, and I'm not comparing any theoretical possibilities, meaning I'm not trying to compare types to untyped, right? I'm not saying dynamically typed is better than typed. I'm not saying typed is better than dynamically typed. I'm talking about languages that have real physical manifestations, real communities, real possible opportunities that they create. And when you look at the whole of those, I prefer Clojure, okay? Even though I still like types. I like types, but I find that I feel better using Clojure. Like I said, this is going to be very personal. I'm going to go deeper into why I feel better about it. But I do want to preface all of this with one more thing. I want to say that Haskell is really well designed. It is up there with Clojure as a language. It's really clean. It's well thought out. For its purpose, I think it's doing a really great job. And it's a pleasure to work with. Okay, so I'm saying all these good things about it just to be sure that these things can stir up a lot of emotions, and I'm just talking about my own preferences. Okay, and I don't think you could ever say that Clojure is better than Haskell in some absolute sense. I would never make that claim. But I do have a preference. I have to choose one usually. You get where do I look for jobs? If I have to get a job, I'm going for Clojure. Okay, so let me just go through. I have a list of things. Before I go into them, I do want to say, so I worked in, there's just a little context. I have been really fascinated by Lisp for a long time, like starting in 2000, 2001. I got really into it, and just over the years, picked up a lot of Common Lisp, then moved into Clojure, and I've just been very happy there. So I have a bias that I have a lot more history with Lisp, a lot more experience with it. So I'm definitely better at Lisp than I am at Haskell. Okay, I'm not an expert at Haskell or anything, but I did work in a job in Haskell for almost 3 years, and I got to know at least the beginnings of the type system. I could get code to compile. It took a while, but I did eventually learn to write code that would compile the first time, a lot of the time. Okay, sometimes, the compiler finds things that you couldn't foresee. But I was writing production Haskell code, making decisions about what libraries we needed to use, modifying existing code, designing new parts of the system, new features. I was in Haskell land, okay? But it's just one job, okay? That's another thing, is it took me a long time I left that job in 2013. Yeah, 2013. And it took me a long time to figure out, I guess, to separate out, like, what part was it about that code base? It wasn't Haskell, it was the code base and our coding style and practices, versus, like, what did I not like about the job and what domain we were working on, versus what was Haskell that I didn't like, right? So there was a lot going on there. And I left that job for a Clojure job, and I was very happy being in Clojure. But again, it was a specific job that had a lot of other good things about it. And so, it's hard to pull these things apart. And of course, this was back in 2013, so things might have changed. Everything that I say might have changed since then. Okay, so I'm going to get started here. So the first thing that Haskell has is that, I would say that, this is just my interpretation of it, but this is the feeling I get, is that they value type safety or type soundness over pragmatism. And this makes a lot of sense. And, I say I'm just, it's just a feeling, but they actually say that, right? It's part of the DNA of the language. They say something like, be impractical at all costs, something like that, where they're not worried about if it's practical. They're worried first and foremost about it being mathematically sound, right? Logically sound. And this is great for a research language, which is Haskell's main purpose. But I found a lot of difficulty with it in working with it, in an engineering situation where I had to make features work. I'm going to tell a little story. So I was doing a feature and I needed to talk to an API, and so I needed to choose an HTTP library. And there were certain constraints that really meant that, well, there were certain features that I needed in that client library. And the real weird one, the weird feature was that we needed to be able to specify our own certificate file. Like an HTTPS certificate, an SSL certificate, because we were talking to a certain API that had a self-signed certificate. It wasn't with the main certificate authorities, and they had sent us out of band the certificate that we needed to use to verify their thing. Okay, and then there were a couple of other things that I needed to be able to do. And so I went looking for an HTTP library. Found many in the Haskell, in the hackage, right? And I started looking at the features, like how do I set the certificate file, and it was kind of easy because some of them I would just say, oh, it doesn't do that, so let's just cross it off the list. Some of them was a little more involved to see what features they had because they weren't well documented, etc. Which happens with all ecosystems, right? It's normal to have, I'm not faulting Haskell for that. Just trying to tell the story. And then I was like, well, I should be looking for something like libcurl, because Haskell uses C libraries the same way Clojure uses Java libraries and wraps them. Haskell uses C libraries and wraps them. So I looked for the libcurl, because that's kind of like, libcurl can do everything, right? So I found a libcurl. It was called something like Haskell curl or something like that. Anyway, I don't remember the name, but it was something like, clearly this is the curl library. And it had it was wrapping libcurl, like that's what it did. And what the author of this library tried to do, a very noble thing, was try to put some safety around the options. Libcurl is a C library that takes all of its options as strings. And so there's the chance that you will pass in like the wrong format of the string, or you're supposed to put a number there, inside of a string, right? A number in the string, but you don't put a number. And so, at runtime, you get an error. And so this author was trying to fix that at compile time by saying this needs a number and this needs and it's a very noble thing, right? But the problem was that it was not complete. It did not have every single possible option. It had like most options and the most popular options. And guess what option it didn't have? Setting an SSL certificate. And so I looked for a backdoor because look, it's libcurl. There's got to be a way to just pass it the strings, just to bypass the type, bypass this options type that they created, and they didn't have one. So I went through all of the HTTP libraries I could find, and they all were crossed off the list for, missing one feature or another. And I told this to some coworkers, and two separate coworkers, one at a time. They both said, no, that can't be right. And they looked and they concluded the same thing. And these are people that were much more into Haskell than I was, so they didn't have the same biases that I was bringing up. And long story short, we wound up writing shelling out to curl, like the curl command line. We would shell out to curl because you could set whatever options you want with strings, and that's what we did. And it was not type safe; it was just strings. But at runtime, especially in development, you're probably going to test out all those strings anyway. So it worked out; it was fine. But the main thing that the point of this story is that a Clojurist would have left the back door. A Clojurist would have written it so that you could have bypassed it if you wanted to. If only just because they would think, okay, I'm gonna give all this safety, that's great, but what if I didn't finish the library, right? What if there's a new option? I don't want to have to release a new version just to get that option, right? And make people upgrade and stuff. They should be able to just upgrade curl and get that new option. Or maybe they are compiling curl with different options that I didn't know about, So there's just this more pragmatic notion in Clojure. In fact, you might have even seen that the Clojure one would have two libraries. Maybe not two libraries, but two modules in the same library. One was the totally unsafe version that called libcurl, lets you pass in a bunch of strings, and it does no checks. It just passes them straight through. So that's kind of like the minimal wrapper, so that you could use it from Haskell, but it's basically it just does whatever libcurl does. And then there would be another one where it's like, well, if you want a better type safe way of generating the options, here's a type that can convert into the array of strings that you would pass into curl. That's how a Clojurist would approach it. They would start with the first one, the simpler one, the one that does as little as possible, and then optionally let you use this other one, and then encourage you to use it, of course, but it would just be a totally separate thing. Okay, so that was number one. So I say that I prefer pragmatism over type safety. I mean, for a case like this where they are in conflict, I mean, I got to get my job done. And this library, I mean, it's probably useful to a lot of people, but it wasn't useful to me, and it could have been. There's no reason why there couldn't have been just like a thing that says like unsafe, do not use is the name of the type constructor, right? But it didn't have that. And in my experience in the Clojure library, those things are there. Okay. So number 2. So types are really nice because they often simplify your code, the value level code, right? So there's all this stuff about the types, and then there's all the stuff that's kind of like what's going to get executed at runtime. And that is called the value level because you're just talking about the values, like add 1 to this and whatever. And that if you put more stuff in the types, there's fewer checks you have to do, like things kind of work out better. If you're working at an abstract level, start using type classes and stuff. You can simplify your value level code, which is great. But very often in libraries, like, part of the same story, I would open the library, the documentation for it, and there's just a mass of type information that you have to learn, even just to evaluate whether there is this has all the features you need, right? So I would start reading about these types, and they have all these definitions, like, okay, how do these interact, and how am I supposed to use them? There's just a lot going on there. And I talked to someone who's very into types, and about this, because it was kind of bugging me. It was like I can't learn some weird type just to know whether the library is going to do the right thing at the value level, right? You really have to trust that they got the type right, to be able to represent the value that you need. And so I talked to him about it, and he said, yeah, that's a thing that, in general, what's happening is people are moving complexity from the value level into the type level. So they're having fun working at the type level. That's like solving a puzzle. It just feels really good to like invent things and make machinery and stuff. And then look how clean my value level code is. But man, to understand how that type level machine works, it's a lot of work. And it dawned on me that what I was seeing, especially in this case of someone trying to make the options to curl type safe, what they were doing, and the reason it didn't have all the options, was it was just like a little pet project. Like, let me see if I can do this. Let me see if I can, push. It spread the Haskell philosophy of type safety over this, C philosophy curl library that just uses strings for everything. Let me see if I can do it. Let me see if I can figure out cool types that represent the whole thing. And I could just see it happening. Is like people are just kind of playing. Now, some people are getting work done, and that's cool. But a lot of the libraries I looked through seemed much more like theoretical. Like, let me see if I can do this, and that's fine, right? Haskell is a research language, and people should be playing and exploring the type system. But as a programmer, as an engineer trying to ship features, that was an impediment. Instead of trying to figure out like what are the ergonomics of this in total, not just the ergonomics of the value level code, but the whole ergonomics of it, they were focused more on showing off in the types. I'm exaggerating. I don't know, and I'm projecting. I don't know exactly what they were doing, but that's often what it felt like. And I don't feel that in the Clojure community. I feel like there's very straightforward patterns that people use. You learn the patterns, and the patterns are simple things like options go in a map. The name of the option is the key, and the value is an appropriately typed value for that option. And it's really simple. Simple. I mean, it's easy. It's straightforward, and you don't have to have like new types. We just use exceptions. We don't have to come up with new error types. It just is straightforward. Okay. Number 3 is kind of I guess it's an ironic thing. So once I had, internalized enough of the type system to have my own type discipline, because at first I'm trying to do things that I was used to doing and they wouldn't work, and I would wonder why, and then I'd get a compiler error, and then I'd eventually figure out, oh yeah, that can't be sound. I can see why the compiler is complaining, and eventually you internalize some, like a bag of tricks for like, okay, I can do this, but I can't do that, and it turns into some useful coding skills. You can get anything you want done within the type system, and that kind of keeps growing as you learn more stuff. I remember when I first learned how to make a monad transformer, like, oh, okay, now I understand how they work, and I can make my own, and it just kind of keeps growing. And then when I went to Clojure, I had that all in my head. Like, I had this discipline of only return values of the same type from a function. Other Clojure programmers would be perfectly happy. I would have before I learned Haskell. Okay, some branches I'll return a string, some I'll return an int. I'll figure it out later in another piece of the code that calls it. Like, I would do that. But after learning Haskell, I started realizing the value of it. Okay, this always returns an integer. This one always takes a list of integers. It doesn't try to like figure out, oh, you just passed it one int. Okay, let me wrap it in a collection so that, just to be clever and have a little bit better ergonomics. Like it messes with things. And I realized that in Haskell, like, no, the soundness, the straightforwardness of the types is really important. And I could bring that from Haskell to Clojure. But I felt frustrated all the time bringing stuff from Clojure to Haskell. I'm a longtime Lisper. I'm very into like DSLs and ways of using polymorphism to get work done, right? So I had a little thing at my job where if you're the author of this document and your password is this and your user ID matches this, I had a little thing where you could just kind of query for the documents that you needed and just compose up a query right there in Haskell. And everybody hated it. And they didn't just hate it. I could see why they hated my implementation. I was still learning Haskell when I did that. And, I didn't know what I was doing. I just, was exploring. I was playing and trying to figure out how to get it to work. But what I didn't understand was they didn't even like the idea of it. They wanted a straightforward function that said, fetch documents by author ID, and then just do some complicated code in there. And then in another one, and just like do some complicated code, instead of a query language that let them compose the thing up. And So there was that sort of social rejection where, I would do a thing which I thought, okay, I finally got this working. Isn't it cool that you can do this now? Which was a totally like Lispy thing to do. No, total rejection. Like, no, why would we even want that? It doesn't make sense. And then, so okay, this might be the team I was working with. And I'm not saying like all Haskellers are like that. But then a lot of things that I tried, I just couldn't get working. Like, I could not figure out a way to represent the type I had in my head, which I used in Clojure, into Haskell. Okay. So it could be my skill level wasn't enough, but I felt like a lot of times it was simply the design of the language and the type system were like just at odds with those kinds of things I was building. Whereas they're perfectly natural in a Lisp. And so, okay, all this is to say that I felt like it was much easier to transfer stuff from Haskell to Clojure than vice versa. So that's the ironic thing, right? That Haskell can express more stuff than Clojure because you can talk about the types, whereas in Clojure you can't. But it's easier to transfer the good parts from Haskell to Clojure than vice versa. Now those good parts, I have to, I understand in Haskell, a lot of the good parts are built into the compiler. And so, you're getting static checks on them. And then when you transport them over to Clojure, it's all relying on you and your head. But I could still transfer a lot of them. Just from the knowledge. Oh yeah, I learned what a monad is by programming in Haskell. And now I write monads in Clojure. I do. I recognize, oh yeah, this is a monad. That's great. I don't have type classes. I still make monads, right? But to make a DSL that's based on a data structure and put that into Haskell, it's really hard. I mean, you have to write a million types to get it to work. Okay, so that's, like I said, it's just a personal preference. I find that transfer is easier. I can go read about category theory and still do it in Clojure, whereas a lot of the stuff that I want to do in Clojure doesn't translate well. I wish I had a better example of something that I just couldn't get done in Clojure. It has something to do with type classes are a very specific kind of polymorphism. And the thing is, it's not polymorphism like Clojure or Java has, where you can use any type that meets that interface, and you don't know what type it is. And that's the point. You just call the interface methods on it. Whereas in Haskell, the compiler still has to know the type. And I was doing things where I was like, okay, and now here's where I return different things that have the same, that are, using the same type class. So all I do is call methods from the type class on it. So shouldn't it all be good? And there's things like that where people talk about, the ad hoc polymorphism. That's what I wanted to do. And I couldn't do it. Probably ways around it. I'm not an excellent Haskeller, but I was having trouble. All right. This last thing, oh man, this is going to be hard to explain. And it's like this feeling. I'm sure someone has, someone will pick apart my argument. Please do. I want to learn. Okay. So yeah, I would rather get an email from you, just to be clear, where you tell me I'm wrong, than to like read some post on Reddit like blasting me. I understand that when you blast someone like that in a public forum, it benefits other people who, want to see both sides. They got my side on this episode, and now they want another opinion about it. But I would like to learn too. So if you blast me online, send me an email so I know, so that we can talk about it. Okay, so this last one, number 4. So types in Haskell there's a lot of emphasis on like mathematical, logical soundness, which is great. Because if you have an unsound type system, like you're just opening the door for crazy stuff, right? And it doesn't make sense, and you're weakening your type system, and it's a bad idea. But it also seems like there were a lot of design choices in the types and the type system that really preferred a more mathematical formulation of types over a real world formulation. And real world meaning, so you're modeling something in the real world. And the real world has certain complexities to it that you need to capture in your type. There's that. And then there's also, you're writing a program that has to live in the real world and deal with, systems that don't have the same type system, over an API. They have to deal with like incomplete data. So there's a lot of, there's that two sides to it. Like the thing you're modeling does not, the thing you're modeling has a real world complexity to it. And then the interaction that your system is having with the rest of the world is also complex. And one aspect that's been talked about quite a bit now, I think, is with maybe as a type in Haskell, and that it represents this idea of an optional value. And how do you model whether that this value, you might have it or you might not, right? You need to have some notion of that, because you don't have, so not everything is required, right? So you have an optional value. And there's a nice Rich Hickey talk about this, about how making something optional is, it should not affect the clients of an API. So if the API requires something, let's call it X, requires an integer X, and then you make it optional to provide X, the clients shouldn't have to change, because now all the old clients are still providing X, and the new clients can omit X or choose to provide X. And the outward facing stuff shouldn't have to change. Of course, inside you're going to have to change, because now you do have to know and check whether you have the X. That's fine. But the outside clients shouldn't have to change. And when you make something in Haskell go from, let's say, integer, because you're an int, you accept a number, to now saying it's an optional int, so maybe int, it's a type change, which requires recompilation of the clients. And then you're going to have to propagate that maybe outward somehow, right? So now instead of just providing the int, you have to say it's a just int, right? You have to change your code on the client, which you shouldn't have to do. I mean, in theory, right? I'm talking about in the ideal world, you shouldn't have to do that because you're only accepting a wider range of inputs. So the clients shouldn't change. Okay, that's my explanation of a Rich Hickey talk that he gave last year, I think, at the Conj. And when I think about it, I think, well, maybe actually does capture the essence of the like sort of mathematical pure essence of optionality. You either have the value or you don't. So let's represent that as a sum type, right? We're just adding one extra case where you don't have it to the integer case where you do have it. And yes, that makes sense from a very formal, nothing is going to change perspective. But in the real world, optionality is actually more complicated. And if you're talking about API endpoints that change over time, because we do come out with extensions, and software never stops evolving. It doesn't work so well. And he expresses it way better than I ever could, or I even thought of doing it. And when he explained it, I realized, yes, that's the kind of thing I'm talking about, where, yes, maybe just it really does boil down the essence of optionality. But it's only that essence. It's like they made the essence real, and they forgot about the real world implications of it. Maybe they didn't even think of it because that wasn't the point of Haskell, right? And they'll say, it's impractical at all costs or whatever. No, failure at all costs, something like that. So the other thing is at the extremes of trying to make your system more and more type safe, you're pushing more and more checks into the type system, using it more and more. You have this explosion of types because you don't want, for data modeling purposes, like you don't want maybes everywhere in your code. So you kind of push it out into an outer level where you have different. So okay, it's too abstract. I'm going to give a concrete example. We had a type called document, and document represented a document, a saved document. And at some point, we started making a single page application for editing this document, and we needed to save the work of the, in the browser editor back to the server, even if it wasn't complete. So we had this type that we couldn't fill out. We did not have values for a lot of the fields, and you don't know which ones, right? So we could have put maybe everywhere and say, oh, maybe they haven't filled that out, they haven't filled that out, they haven't filled that out. But what we wound up doing was having a thing called a document draft. And the document draft it was a separate type that said, okay, this is a type just for capturing all these values that we have, and kind of ignoring all the values we don't have yet that the user hasn't inputted. And then eventually they would fill out all the fields, or at least all the required fields, and then we could create a document out of it, out of the draft. We would convert the draft into a document. And it's like, yes, that worked. But it would be nice to have some kind of higher level algebraic type that could represent all drafts of all the different types that we had. Instead, we had to write the types, each one, and you could see that there's some similarity between them. Oh, they were just capturing fields and what we have, and we know we don't have the other stuff yet, so we're just, it's okay. We like some kind of higher level thing that we could have made. And maybe it would be possible to sit down and come up with a type that represented all of our things. It probably would be, but it was we never got there, right? And it's just because it would just be an explosion of types. Like it would just be we would try the types and probably get it wrong the first time, and then we'd have to make new types and figure it out and work that stuff out. And I just felt like the stuff that we were given in the language was not trying to address this real world thing. Now, this is where, when I've had this discussion before online, this is where people say, well, you just need to learn the types better, or maybe you need this extension to Haskell, or this language has this other type feature. I understand that there are, there's a variety of type systems out there with different, and you can make your own with Haskell extensions, and different languages have different ones. I understand that. Like the thing was, like, I'm talking about Haskell as what it is, like, as what it was in 2013. I'm not talking about type systems in general. I think it's definitely possible to have a cool solution to this in types. But I'm not talking about that. I'm talking about Haskell versus Clojure. And this is, I'm talking about, this is before spec. This is before other stuff that Clojure has now. Clojure's data structures can be used as this kind of grab bag of fields and values. And that's kind of like all you didn't need to come up with a system for storing incompletely filled out forms. Like it just kind of happens in Clojure. And it's actually hard in spec because Rich Hickey has admitted he got it wrong, that he didn't realize how important this idea of optionality was when he was developing spec. So and he's working on a second version. Okay, so this has gone on way too long now. I want to just say again, I want to learn. So please, be gentle on me when you tell me I'm wrong, because if you're too rough, I won't be able to learn, right? Okay, so I'm gonna give the 4 things again as a recap. So Haskell values type safety or soundness over pragmatism. And when you're doing a very pragmatic thing like making an HTTP request, very often you would rather like risk having a poorly formatted string and get the message across to the other side than be stuck with the types, being not a complete description of the options that you need. Often I found that a lot of the complexity was moved from the value level code to the type level, and that made it difficult to, like, okay, look, if I'm going to use the library, I'll make the investment, I'll learn the types, but just to evaluate the library, it's often hard to, it just takes a lot of time to like understand these types and why I need them, what they're for, poorly documented, stuff like that. Okay. Number 3, type discipline transfers to Clojure, because once you internalize it, it's in your head. Whereas a lot of the stuff that I'm used to doing in Clojure, that it's kind of like advanced Clojure stuff, doesn't translate so well. And maybe it just means I need to study more type theory and category theory and more of the type level features of Haskell, and then I'll be able to do it. But I never got there. And then finally, I think a lot of the types in Haskell are, let's be honest, they're designed for their simplicity and for writing papers about, and use in papers, and they're not really made for real world usage. Now, if they're useful in the real world, then that's great, but that wasn't their main purpose. And Clojure is different. It's made a lot of choices to make sure that in the real world, like it's dealing with these real world issues of, APIs having to evolve over time, incomplete data coming in, poorly formatted data, all of that stuff. All right. This has been a long episode. I try not to go this long, but I felt like this is an important topic, mostly because someone online that I respect asked the question, and he asked, why do I prefer Clojure to Haskell? So there you are. There's your answer. If you like this episode, you can go to lispcast.com/podcast and find all the past episodes. There you'll find video and text and audio of all of the episodes. You'll also find links to subscribe and to find me on social media. Please let me know how I'm wrong. I hope that I didn't say anything that kind of triggers some other arguments that I'm not trying to make. For instance, types versus dynamic. I didn't really go there. Part of it was I had to work with the Haskell type system, and I really thought that it was a good type system. It was very helpful. It was like having a little logician on your shoulder, looking over what you're working on. And I appreciated that. And I miss it sometimes when I work in Clojure. But yet I still find myself preferring Clojure. So there you have it. Okay. Thank you so much. And thank you for listening. My name is Eric Normand. This has been my thought on functional programming. Rock on.